The definition of functions: a relation f from a to b is said to be a functions if domain of f equal to a and range of f is subset are equal to b and f is not an one many function. So there are two cases arises if if range of f is subset or equal to b, that is it is either subset of a, subset of b, or equal to b. If it is equal to, if range of f equal to b, then f is an onto function. If range of f is subset of b, then it is an into functions. And f is not on one many relation, so it is either one or many one. Let's give an example. If cardinality of a equal to m and cardinality of b equal to n, then number of functions from set a to b is n to the power m. How we prove this condition? That is, each element, as set a contain m number of elements, let these elements are a1 to am, and b contain n elements, that is b1 to bn. So each element of set a has n possible ways of images, that is for m different objects, n into n, that is m times, that is n to the power m. Now how many functions are there from the set 1 2 3 to a b c d? That is, here set a contain 3 elements and set b contain 5 elements, so its answer is obviously 5 to the power 3, that is cardinality of b to the power cardinality of a. In this question, how many of those functions have f of 1 equal to e? As f of 1 equal to e, that is f of 1 has only one choices, one option, but f of 2 has 5 possible images, f of 3 has 5 possible images. So the total number of functions is 5 into 5, 1 into 5 into 5, that is 5 square. Second question, how many of those functions of f of 2 not equal to d? That is, f of 1 has 5 possible images, f of 1 has 5 possible images, f of 2 has, as f of 2 not equal to d, so it has 4 possible images, f of 3 has 5 possible images, so that is 5 into 4 into 5, that is 4 into 5 square. How many of this function in which f of 1 equal to e and f of 2 not equal to d? That is, f of 1 equal to e, that is 1 has only one options, f of 2 has not equal to, that is 4 options, and f of 3 has 5 options, that is 1 into 4 into 5, that is 20. F of 1, f of 2, f of 3. We know that a function is said to be 1 if separate elements of set a has separate images in set b. Those functions which are not 1 are many one functions. So a function is either 1 or a many one. If a and b are finite sets, then necessary condition for a function from a to b is 1 if cardinality of a is less than equal to cardinality of b. This means if cardinality of a is greater than cardinality of b, then the function cannot be 1. The number of 1 functions from a to b is npm, that is n factorial by that is factorial of n by factorial of n minus m. The number of many one functions is obviously, as the function is either 1 or many one, so number of many one function is total number of functions minus number of 1 functions. How many functions from a b c d to 1 2 3 4 5 are 1 and many one? Here the answer is 5p4, that is number of 1 function is npm, that is 5p4, and number of many one function is total number of function is 5 to the power 4 minus number of 1 function is 120, that is 505. How many 1 functions in which f of a equal to 1 and f of b is not equal to 2? Here the set a is a b c d and set b is 1 2 3 4 5. Here f of a equal to 1, that is only one option, f of b not equal to 2, and already f of a equal to 1, so the remaining 3 options are out of 1 2 3 4 5, because since f of a equal to 1 and f of b is not equal to 2, so f of b has remaining 3 options, that is 3 4 5, that is 3 options. For set c and d has for c has 3 options and d has 2 options, so total number of 1 function is 1 into 3 into 3 into 2, that is 18. We know that the definition of onto function, a function f from a to b is said to be an onto function if every element subset b has a pre-image in set a. A necessary condition for a function f from a to b is to be onto function is that if cardinality of a is greater than equal to cardinality of b. If cardinality of a is less than cardinality of b, then there will be 0 onto function from A to B. If the set A has n elements and n is greater than or equal to 2, and the set B has 2 elements, then the number of onto functions from A to B is 2 to the power n minus 2. A function is said to be onto function if every element of set B has images in set A. As set B contains 2 elements and the set A contains n elements, then it is an onto function. If not an onto function, if suppose B contains 2 elements A and B, if these elements have no pre-images, then it is not an onto function. If A has no pre-images in set A, then it is not an onto function. Except these two, all functions are onto function. As cardinality of A equal to n, cardinality of B equal to 2, number of function is 2 to the power n, and out of which these two are not onto function, so remaining are obviously onto functions, so 2 to the power n minus 2. Another important formula, number of ways of partitioning this number of elements in k1, k2, km groups such that ki groups contain ni elements is factorial of this by n1 factorial to the power k1, n2 factorial to the power k2, nm factorial to the power km into power exponent. Here exponent is k1, exponent is k2, that is exponent k1 factorial of k1 factorial of k2 up to factorial of km. Suppose take an example. A set A contains 5 elements and set B have 3 elements. Then how many different onto functions will be there from A to B? So to solve this question, we have to arrange 5 elements in 3 different groups. That is, it may be 1 1 3, 1 2 2. Only 2 options are there. If it is 1 1 3, by using this formula, it is 5 factorial by 1 factorial of 1 square into 3 factorial to the power 1 into 2 factorial into 1 factorial. That is, it is here n1 is 1 factorial, n2 is 3 factorial. It's as 1 is repeated 2 times, that is power 2, and 3 is 1 time, that is power 1. It is k1 factorial into k2 factorial, that is 1 factorial, is equal to 10. For 1 2 2, here by using this formula, 5 factorial by 1 factorial into 2 factorial of 2 the square. Since there are 2 times into 1 factorial into 2 factorial, that is power factorial of the exponents, which is 15, that is 10 plus 15 25. So number of partitioning, so number of ways of arrangement of 5 elements in 3 groups is this. Now as 5 is divided into 3 groups, so total number of onto functions is 25 into 3 factorial. Since as 5 number of these elements are divided into 3 groups, that is, it has 3 options, it has 2 options, it is a 1 option, so 3 factorial ways. So total number of onto function is 25 into 3 factorial, that is 150. Let us take another example. Suppose first we know the definition. If cardinality of A equal to m and cardinality of B equal to n and m is greater than or equal to n, then number of onto functions from A to B is equal to number of ways of partitioning m objects into n groups into factorial of n. Let us take another example. If cardinality of A equal to 6, cardinality of B equal to 3, then number of how many different onto functions will be there from A to B. So to solve this question, first we have to divide 6 into 3 groups, that is 4 1 1, 3 2 1, 2 2 2. So by using the previous formula, its number of ways of arrangement is 6 factorial by 4 factorial into 1 factorial square into exponent is 1, that is 1 factorial into 2 factorial. For 3 2 1, it is 6 factorial by 1 factorial, 2 factorial, 3 factorial. For 2 2 2, that is 6 factorial by factorial of 2 the cube into 3 factorial. Its total number is 90. As it divided into 3 groups, so 90 into 3 factorial, that is 540. Let's take another example. From this to this number of onto functions. So first we have to separate these 7 elements into 4 groups, that is 1 1 1 4, 1 1 2 3, 1 2 2 2. So its number of arrangement is 7 factorial by 1 factorial cube into 4 factorial into its power exponent is 3, that is 3 factorial. Similarly 1 1 2 3, that is 7 factorial by 1 factorial of 1 square, factorial of 2 to the power 1, factorial of 3 to the power 1 into 2 factorial. Similarly 1 2 2 2, that is n factorial by 1 factorial into 2 factorial, factorial of 2 the cube into 3 factorial, its total number is 105. So 35 plus 210 plus 105, that is 350. As divided into 4 groups, that is into 4 factorial, that is 350 into 4 factorial is equal to this. Here the question is number of, suppose you have to find out the number of into functions. For number of onto function we calculate this. For number of into function, as we know that a function is either onto function or into function, so number of into function is total number of functions minus number of onto functions, that is this minus this. So